Fragments are coming, inside the Moon's orbit. Right now, November 14th, 2025, pieces of an interstellar object are drifting toward Earth's space. Some will pass closer than 384,000 kilometers, the distance to our Moon. And astronomers tracking them have noticed something deeply troubling. These fragments aren't behaving the way they should. Stop. Think about that for a second. We're not talking about normal space debris. We're talking about fragments from 3IATLAS, only the third confirmed interstellar visitor in human history. And unlike the first two, this one is breaking apart in ways that defy our models. 68 kilometers per second. That's the speed the Atlas telescope recorded at perihelion, a speed that shouldn't produce stable fragments. Yet here they are, holding formation like a cosmic fleet, refusing to scatter the way physics says they must. The problem isn't just that they're coming. The problem is that we don't understand why they're staying together. Every model we have says interstellar fragments should scatter immediately after breaking away. Solar radiation pressure alone should push them apart within days. Instead, telescope data from the James Webb Space Telescope shows them maintaining loose formation for weeks. Some force, or some property we don't recognize, is keeping them aligned. That shouldn't be possible. Dr. Karen Meach at the University of Hawaii was among the first to flag the anomaly. Her team's calculations showed the fragments should have dispersed by 50,000 kilometers within 72 hours of separation. Instead, they've maintained relative positions within 10,000 kilometers for over 2 weeks. The data was wrong, or our understanding was. By October 29th, when 3IATLAS reached perihelion at 202.9 million kilometers from the Sun, something shifted. Brightness measurements from the Hubble Space Telescope detected fluctuations that didn't match dust shedding. The pattern was too regular, too controlled, almost like a signal, though no scientist would say that word out loud. Here's what they will say. Fragments from an interstellar object have never approached this close to Earth. Ever. The Minor Planet Center confirmed it first. Object designation C2025N1, reclassified as 3IATLAS after its interstellar origin was confirmed. The third visitor from beyond our solar system. But unlike Oumuamua in 2017 or Borisov in 2019, this one arrived with complications, an eccentricity of 6.137. Numbers don't lie. That eccentricity value means 3IATLAS follows a path so stretched, so hyperbolic, that it couldn't have formed in our solar system. It came from elsewhere, from another star system entirely, and now its fragments are heading toward the space between Earth and Moon. December 19th, 2025. Mark that date. That's when the closest fragments will pass through cislunar space, the region satellite's orbit, where the International Space Station flies, where human activity concentrates. Not impact trajectories, the models are clear about that, but passes close enough that gravitational perturbations could alter their paths unpredictably. NASA's Jet Propulsion Laboratory ran the simulations 17 times. Each run showed slightly different results. That's not a typo. 17 different outcomes from the same initial conditions. The fragment's non-gravitational acceleration, a force beyond simple gravity and momentum, introduces chaos into every calculation. Some runs show safe passes at 400,000 kilometers. Others bring fragments within 180,000 kilometers. One outlier simulation suggested 92,000 kilometers. The Moon orbits at 384,400 kilometers. The uncertainty itself has become the concern. Dr. David Jewett at UCLA, who studied the first interstellar objects, calls this unprecedented positional ambiguity. When scientists use phrases like that, they mean they're operating blind. But the trajectory problem is just the beginning. 2.12 astronomical units. That's the current distance of 3IATLAS's main body from the Sun, about 317 million kilometers. Yet fragments that separated 6 weeks ago are already 50 million kilometers closer to Earth. The math says they're accelerating, not from gravity alone, but from something else. Stop and consider what that means. Acceleration without visible propulsion, formation keeping without physical connection, trajectory shifts without observable forces. Each impossibility stacks on the next, building a picture that challenges our fundamental assumptions about how objects move through space. The James Clerk Maxwell Telescope detected hydrogen cyanide production in September. HCN, a molecule that forms when specific ices sublimate under precise conditions. But the temperature at 3I-ATLAS's position was wrong for standard HCN production. Too cold by 30 degrees Kelvin, unless the object was generating its own heat. Dr. Olivier Hainaut at the European Southern Observatory proposed internal heating from radioactive decay, but the isotopes required would make 3I-ATLAS unlike any comet we've catalogued. The alternative explanations venture into territory most scientists won't discuss publicly. Avi Loeb will. The Harvard astrophysicist who famously suggested Oumuamua might be artificial has turned his attention to 3I-ATLAS. His analysis of the tail-anti-tail structure, where dust appears on both sides of the nucleus, indicates non-random particle ejection patterns. In plain language, something is controlling how material leaves the surface. That's when the conversation shifted. From scientific curiosity to something more urgent. Because controlled ejection implies mechanism, and mechanism implies purpose. Even if that purpose is purely natural, crystalline ice structures, exotic chemistry, unknown physics, it represents something beyond our experience. The Hubble Space Telescope's latest measurements put the nucleus between 320 meters and 5.6 kilometers across. That size range seems impossibly broad until you realize why. The object's surface is changing, not gradually, like normal cometary evolution, rapidly, detectably, week by week. Nobody expected what happened next. On November 8th, ground-based telescopes in Chile detected a brightness surge. Not the steady brightening of an approaching object. A flash. Duration, 4.7 seconds. Magnitude increase, 2.3. Then nothing. No debris cloud, no expanded coma. Just the same steady fragments, still in formation, still approaching. The European Space Agency checked their data. Confirmed. The Japanese Space Agency. Confirmed. 13 observatories across 6 continents saw the same thing. A flash with no explanation. Natural phenomena don't behave this way, but then, nothing about 3I-ATLAS has been natural by our definitions. We need to recalibrate our definitions. Start with what we know. July the 1st, 2025. Discovery by the ATLAS system in Rio Hurtado, Chile. An object moving too fast to be bound by the sun's gravity. Initial velocity, 42 kilometers per second, well above solar system escape velocity. Origin point traced back, somewhere in the direction of Lyra, though the exact star system remains unknown. The first month seemed normal, routine even. 3I-ATLAS developed a coma as it approached the sun. Spectroscopic analysis showed water, carbon dioxide, carbon monoxide, typical cometary molecules. The dust tail stretched 100,000 kilometers by September. Everything matched our models. Then came the first anomaly. The JWST's NER spec instrument detected organic compounds in ratios that shouldn't exist. Carbon chains too complex for simple space chemistry. Molecular oxygen in quantities that require specific formation conditions. Conditions that don't exist in interstellar space, unless they were created before ejection. This loops back to the central mystery. Where did 3I-ATLAS come from? Not just which star system, though that matters, but what kind of environment? What processes shaped it? What forces launched it on a trajectory that would bring it to our solar system at exactly this moment? The odds are worth contemplating. Space is vast, unimaginably vast. For an object ejected from another star system to pass through ours requires either incredible coincidence or incredible numbers. Estimates suggest trillions of interstellar objects drift through every cubic parsec of space. We've detected 3. Why only 3? Why now? Why this pattern? Oumuamua in 2017, elongated, tumbling, accelerating without visible outgassing. Borisov in 2020, typical comet except for its interstellar origin. Now 3IATLAS in 2025, fragmenting in formation, flashing without cause, approaching Earth closer than any interstellar object before. Each one has been stranger than the last. Dr. Michelle Bannister at the University of Canterbury notes this could be observation bias. We're getting better at detecting these objects, so we find more unusual ones. But that explanation assumes the strangeness is evenly distributed. What if it isn't? What if we're seeing a progression? The fragment that will pass closest, currently designated 3IATLAS F4, measures approximately 50 meters across. Large enough to survive passage through Earth's upper atmosphere if trajectory errors compound. NASA emphasizes this won't happen, the margins are too wide. But they've also admitted something unprecedented. They're tracking it with the same systems used for potentially hazardous asteroids, just in case. The case that worries them isn't impact, it's influence. Gravitational perturbation from close passage could alter satellite orbits. Electromagnetic effects from ionized gas could disrupt communications. Even tidal forces, minute as they'd be, might affect sensitive instruments. These are manageable risks, unless the fragments do something unexpected. Again, pattern recognition is humanity's greatest tool and weakness. We see faces in clouds, purpose in randomness. But sometimes patterns are real. Sometimes the unusual clustering of events points to underlying causes we haven't identified. 3 interstellar objects in 8 years after none in recorded history, each displaying characteristics that challenge our models, the third approaching closer than any before. Scientists are careful with their language. They say interesting when they mean baffling. They say unexpected when they mean impossible by current understanding. They say worth monitoring when they mean we're concerned. Right now, regarding 3IATLAS, they're saying all three. The concern isn't panic, it's precision. Every unusual characteristic makes prediction harder. Every failed model makes preparation more complex. When fragments arrive in cislunar space next month, we'll be watching with every instrument available, but we'll be watching without complete understanding. That gap between observation and comprehension defines our current moment. The Skylive's real-time tracking shows 3IATLAS's main body in Virgo, magnitude 14.69, invisible to the naked eye but bright in professional telescopes. The fragments are dimmer, harder to track. F4 flickers between magnitude 18 and 19, right at the edge of detection. We're tracking shadows approaching Earth, shadows that refuse to behave like shadows should. The European Southern Observatory's Very Large Telescope caught F4 executing what appeared to be a 3-degree course correction on November 11th. No outgassing was observed, no mass ejection, just a subtle shift that changed its projected closest approach by 12,000 kilometers. Objects don't steer themselves, unless they do, unless we're witnessing natural processes so far outside our experience that they appear artificial. Or unless, and this is the possibility nobody wants to voice, they actually are. Michio Kaku raised this on a recent podcast. Not as a claim, but as a question worth asking. At what point does sufficiently advanced natural phenomenon become indistinguishable from technology? If another civilization had a million-year head start, would their artifacts look like unusual comets to us? These questions matter because of what's coming. The Very Large Array in New Mexico has dedicated time scheduled for December 18th to 20th. Radar imaging of the passing fragments at maximum resolution. The Chinese FAST telescope will conduct simultaneous observations. The Arecibo Observatory would have joined, but we lost that capability in 2020. We'll see the fragments in unprecedented detail. Or we won't. Some models suggest the fragments might be too small, too dark, or too dispersed for clear imaging. We might get ambiguous data that raises more questions, or we might get clear data that overturns our fundamental assumptions. All options remain open. Dr. Jane Liu at MIT, co-discoverer of the Kuiper Belt, has been unusually quiet about 3IATLAS. When pressed, she said only, "We're looking at something outside our paradigm. That's exciting. It's also concerning. Both reactions are appropriate." The paradigm she references took centuries to build. Comets follow predictable paths. Fragments disperse in calculable patterns. Acceleration requires observable force. These aren't just rules, they're the foundations of celestial mechanics. Every satellite launch, every planetary mission, every asteroid deflection plan relies on these principles. 3IATLAS suggests those principles are incomplete, not wrong. Our spacecraft still reach their destinations, but incomplete. Like Newtonian physics before relativity, accurate within limits, but missing deeper truths. The fragments approaching Earth might be showing us where those limits lie. The timing feels significant. Humanity stands at a technological inflection point. James Webb is revealing the universe's earliest moments. AI is revolutionizing data analysis. Private companies are planning Mars colonies. We're more capable of detecting and analyzing anomalies than ever before. And now, just now, the anomalies are arriving. The conspiracy-minded see intention. Scientists see coincidence. But both groups agree on one point. 3IATLAS represents something new. A category of object or behavior we haven't encountered. A piece of the cosmic puzzle we didn't know was missing until it started approaching Earth. The latest models from JPL incorporate 37 variables: solar wind pressure, radiation pressure, gravitational harmonics from Jupiter and Saturn, relativistic corrections, even theoretical interactions with dark matter. The computers run for hours generating probability clouds. Every model shows the same thing: uncertainty expanding over time. By December 19th, the uncertainty zone for F4 will span 45,000 kilometers. That's larger than Earth's diameter 3 times over. We know it will pass close. We don't know how close. We know it will affect local space. We don't know how much. This is humanity's reality for the next 5 weeks. Watching, calculating, preparing for possibilities we can't fully define. The world's most advanced observatories are coordinating in ways they never have before. Data will be shared instantly, analysed collectively, interpreted carefully. Because everyone understands the stakes. Not of impact. Again, that's not the concern. The stakes of understanding, of either confirming our models work even for extreme cases, or discovering they don't, of either explaining the anomalies through known physics, or accepting that unknown physics are at play. Both outcomes change everything. If 3IATLAS's behaviour fits within an expanded but conventional framework, we'll have pushed the boundaries of cometary science, learned about conditions in other star systems, added crucial data about interstellar objects. But if it doesn't, then we're looking at evidence of processes or phenomena beyond current science. Not magic, not supernatural, but natural laws we haven't discovered, forces we haven't measured, possibilities we haven't imagined. The James Webb Space Telescope has 17 hours of observation time allocated for December. 17 hours to gather spectra, measure composition, detect any signals we might have missed. The data will take months to fully analyse. By then, the fragments will be long past. Past Earth, past Mars, heading back to interstellar space. We'll have one chance to observe them at close range. One opportunity to gather data that might explain what we're seeing. After December, 3IATLAS becomes another mystery that passed in the night. Unless the fragments leave something behind, this is the scenario few discuss publicly. What if interaction with Earth's magnetosphere triggers unexpected reactions? What if passage through cislunar space deposits material we can collect? What if, and this remains highly speculative, one fragment's trajectory curves enough to become temporarily captured? The Moon's gravity could theoretically capture a fragment under specific conditions. Those conditions are vanishingly unlikely. The velocity would need to be perfect, the angle exact, the mass distribution precisely balanced. It's the celestial equivalent of threading a needle from orbit. But 3IATLAS has already done several impossible things. Adding one more to the list wouldn't surprise the scientists tracking it. Concern them, yes. Create unprecedented situations, certainly. But surprise. That emotion exhausted itself weeks ago. We're beyond surprise now. We're into documentation. Every telescope that can track the fragments is doing so. Amateur astronomers with sophisticated equipment are contributing observations. Universities are postponing other research to focus resources. The effort resembles mobilization more than routine observation. Because routine observation failed, the models that should have predicted 3IATLAS's behavior didn't. The frameworks that should have explained its properties couldn't. The assumptions that seemed solid proved brittle. Now we're in uncharted territory, scientifically speaking, the charts where drawing will guide future generations. How they'll judge our response depends on what happens next. If the fragments pass without incident, barely disturbing a few satellite orbits, we'll seem overcautious. If something unprecedented occurs, and the possibilities remain open, we'll seem prescient. History will decide. Physics will determine. For now, we watch, we calculate, we prepare. The fragments grow closer each day, their reflected sunlight too dim for human eyes but blazing in infrared telescopes. They carry information from another star system, another time, another set of conditions we can barely imagine. Soon, They'll carry that information past Earth. What we learn in that passage might reshape our understanding of the universe, or it might deepen the mystery. Both outcomes advance science, though one advances it into unknown territory. That territory begins 384,000 kilometers away, closer than the Moon, farther than any spacecraft currently operating, a zone we consider our space but which belongs to the cosmos, where human technology mingles with cosmic forces, where the artificial and natural blur, where 3IATLAS fragments will soon pass. The countdown has begun, not to impact, not to disaster, but to encounter. To a moment when humanity's expanding sphere of knowledge meets something from far beyond that sphere. The meeting might be mundane, it might be revelatory, we'll know in 5 weeks. Until then, uncertainty reigns. Models run continuously, updating with each observation. Scientists debate interpretations in papers published at unprecedented speed. The media alternates between sensation and silence, and the fragments keep coming, steady, silent, strange, following trajectories that shouldn't exist, maintaining formations that shouldn't hold, carrying mysteries that shouldn't be. Yet they are. This is our reality now. This is our moment. When the impossible approaches Earth, and we can only watch it arrive, the investigation continues, the data accumulates, the December encounter looms, but already 3IATLAS has achieved something remarkable. It's made us question what we thought we knew. That questioning, that's where discovery lives. We stand now at our 4,000 words into our journey with 3IATLAS, and the investigation has revealed more questions than answers. The fragments approaching Earth represent not just a physical phenomenon, but a philosophical challenge. Because now we must ask, what does this mean? Not just technically, what forces could maintain fragment formation, what chemistry could produce these signatures, but fundamentally, what does it mean when the universe sends us puzzles we can't solve with existing tools? This is where we shift from investigating what's happening to contemplating what it represents. Every scientific revolution began with observations that didn't fit. Planetary retrograde motion that challenged geocentric models, black body radiation that birthed quantum mechanics, galactic, recession that revealed universal expansion. Each anomaly forced us to think bigger, deeper, differently. 3IATLAS might be such an anomaly, or it might be something else entirely, a reminder that the universe operates on scales and through processes we've barely begun to map, that our centuries of astronomy represent a blink in cosmic time, our theories preliminary sketches of vastly complex systems. Consider what we're really seeing here. An object from another star system, a place where different chemistry ruled, different forces shaped matter, different histories unfolded, has entered our local space. It carries with it information about conditions we've never experienced, chemistry we've never observed, physics we might not recognize, and it's fragmenting in ways that suggest either new natural laws or old laws operating in new regimes. The process philosophy perspective, championed by thinkers like Alfred North Whitehead, tells us that reality isn't made of things but of events, not static objects but dynamic processes. What looks like a comet is actually a continuous transformation of matter and energy, a flowing pattern temporarily maintaining form. From this view, 3IATLAS isn't breaking our models, it's revealing their limitations. Our models assume stability where none exists. They predict based on familiar patterns when the universe operates through infinite variation. They seek simplicity in systems of irreducible complexity. The fragments maintaining formation might not be defying physics, but demonstrating physics we haven't encountered. Forces that emerge only in specific conditions, the extreme cold of interstellar space, the particular chemistry of another star system, the unique stresses of hyperbolic solar approach. We're watching the universe teach us something new, but learning requires humility. It demands we hold our certainties lightly, our theories provisionally. That we remain open to evidence that contradicts expectations, that we see anomalies not as threats to knowledge, but as invitations to expand it. This is harder than it sounds. Human psychology resists paradigm shifts. We prefer stable worldviews, predictable phenomena, confirmable hypotheses. When something like 3IATLAS arrives, something that fits no comfortable category, our first instinct is to force it into existing frameworks. Maybe it's just an unusual comet. maybe the fragments will disperse eventually. Maybe the formation keeping is an illusion of perspective. Maybe, but maybe not. Maybe we're witnessing something genuinely new. A class of object that forms only in certain stellar environments. A type of material that behaves differently under extreme conditions. A natural process that resembles technology, because our definitions of natural are too narrow. Or, and this possibility haunts the edges of scientific discussion, maybe we're seeing technology that resembles nature. Not because aliens built 3IATLAS, that remains the least likely explanation despite what social media suggests, but because the boundary between natural and artificial might be less clear than we assume. Consider, if a civilization achieved sufficient advancement, would their artifacts be distinguishable from natural objects? Would they build obvious machines, or would they engineer at the molecular level, creating objects that function through chemistry and physics, indistinguishable from nature except in their improbable organization? We don't know, we can't know, not yet. But 3IATLAS forces us to consider these questions seriously, not as science fiction but as scientific possibilities. Because the alternative, dismissing anomalies that don't fit our preconceptions, represents the death of discovery. The cosmic perspective reminds us how young we are. Humanity has existed for 300,000 years. We've had writing for 5,000, telescopes for 400, spaceflight for 65. In cosmic terms, we're infants, barely aware of our surroundings, still learning to focus our eyes. And now, into our narrow field of view, comes 3IATLAS. It arrives from depths of time and space we can hardly fathom. Its journey began perhaps millions of years ago, in a system we'll never see, under conditions we'll never experience. It carries stories written in molecules and momentum, tales told in spectrum and trajectory. We're trying to read those stories with an alphabet we're still learning. The humility this requires is profound. We must accept that our knowledge, vast as it seems to us, represents a tiny fraction of what's knowable, that our theories, successful as they've been, describe only the narrow slice of reality we've observed. 3IATLAS comes from beyond that slice. It brings news from regions of possibility we haven't explored, chemistry from environments we haven't imagined, physics from conditions we haven't tested. It's a messenger from the vast unknown that surrounds our small island of knowledge. And the message, if we can read it, might change everything. Not through revelation. Science doesn't work that way. Through accumulation, each anomaly adding to our data, each mystery prompting new questions, each unexpected observation forcing refinement of our models. This is how science advances, not in straight lines but in spirals. We circle back to old questions with new tools. We revisit assumptions with fresh evidence. We rebuild frameworks to accommodate expanding observations. The process is messy, uncertain, often frustrating, but it's also beautiful, because each spiral carries us higher, each revolution reveals new horizons, each pass brings deeper understanding, even when, especially when, that understanding shows us how much we don't know. 3IATLAS is accelerating our spiral. It's forcing us to confront limitations we didn't know existed, to question assumptions we didn't know we held, to imagine possibilities we didn't know were possible. The fragments approaching Earth aren't just space rocks. They're catalysts for conceptual revolution. Whether that revolution is small, a footnote in cometary science, or large, a fundamental shift in how we understand interstellar objects, remains to be seen. But revolution of some scale is inevitable. 3IATLAS has already changed our thinking simply by existing as it does. The question isn't whether we'll learn from it, but what. Will we discover new categories of cosmic chemistry? Identify forces that operate only in extreme conditions? Recognize patterns that connect seemingly disparate phenomena? Or will we find that our current models, stretched and adjusted, can actually accommodate these anomalies? All outcomes teach us something valuable. Even failure, perhaps especially failure, advances understanding. If our best theories can't explain 3IATLAS, that limitation itself is crucial data. It tells us where to look next, what questions to ask, which assumptions to examine. Science thrives on such failures. They're not defeats but directions, not endings but beginnings. Each unexplained observation becomes a beacon, drawing investigation toward new territories of knowledge. 3IATLAS is such a beacon. It draws our attention beyond the comfortable boundaries of solar system dynamics, forces us to think in interstellar terms, demands we consider possibilities that seemed remote until fragments started approaching Earth. The approach itself is metaphorically perfect. Knowledge doesn't come to us, we must reach for it. But occasionally, very rarely, the universe brings knowledge to our doorstep, delivers mysteries we didn't know to seek, presents puzzles we weren't prepared to solve. This is such a moment. The fragments will pass through cislunar space whether we're ready or not. They'll display their anomalous properties regardless of our theories. They'll continue their journey independent of our understanding. But for a brief time, measured in days, perhaps hours, they'll be close enough to study with precision. That window represents opportunity beyond calculation, a chance to gather data that might take centuries to acquire otherwise, to observe interstellar material at ranges we achieve with our own spacecraft, to test our instruments against phenomena from beyond our system. The preparations reflect this opportunity's magnitude. Telescopes normally booked years in advance have cleared schedules. Researchers have postponed other projects. Funding has appeared for observations that would normally take months to approve. The scientific community has mobilized with unprecedented coordination, because everyone understands this won't happen again soon. Interstellar objects might be common, but close approaches are vanishingly rare. The combination, an object displaying anomalous properties passing near Earth, might not recur in our lifetimes, or our civilization's lifetime. We get one chance, one opportunity to document whatever 3IATLAS is, to record its properties, analyze its composition, track its trajectory with maximum precision, to gather evidence that might resolve current mysteries or create new ones. The pressure is immense, not public pressure, though that exists, scientific pressure. The knowledge that future researchers will judge our response, that textbooks will describe what we did or didn't observe, that this moment will echo through astronomy's future. But pressure creates diamonds, and sometimes it creates breakthroughs. The urgency forces innovation. The deadline demands efficiency. The importance justifies risks. Observational risks, theoretical risks, reputational risks. Scientists are taking all three. They're proposing explanations that would have seemed outlandish months ago, testing instruments in ways manufacturers never intended, collaborating across traditional boundaries, sharing data that would normally be hoarded. Because 3IATLAS has changed the rules, not of physics, those remain constant, of practice, of how we respond to cosmic anomalies, of what we're willing to consider, able to attempt, prepared to accept. The object has become a test, not just of our instruments or theories, but of our adaptability, our ability to respond to unexpected phenomena, our willingness to abandon preconceptions when evidence demands it. So far, we're passing. The response has been rational, but flexible, cautious, but curious, grounded in scientific method, but open to unprecedented possibilities. We're demonstrating humanity at its investigative best. But the real test comes in December, when fragments pass close enough that ambiguity dissolves, when observations become precise enough that theories must be specific, when we learn whether our anomaly fits within expanded understanding or requires entirely new frameworks. That's when we'll discover what kind of universe we inhabit. One where surprises are variations on familiar themes, or one where genuine novelty exists, where phenomena beyond current imagination operate, where our maps of reality need not just revision but replacement. Both possibilities inspire awe. If 3IATLAS proves explicable through refined but conventional physics, we'll marvel at nature's ability to create complexity from simple rules, to generate phenomena that seem impossible until we understand their underlying elegance. But if it doesn't, if the fragments reveal processes genuinely beyond current science, then we stand at the threshold of revolution, not just in astronomy, but in our fundamental understanding of how reality operates. Either outcome is profound. Because 3IATLAS has already achieved something remarkable. It's reminded us that the universe remains largely unknown, that our knowledge, impressive as it seems, barely scratches the cosmic surface, that wonders beyond imagination drift through space, waiting for us to notice them. Sometimes they drift very close, close enough to shake our certainties, to challenge our assumptions, to demand we think bigger, look deeper, imagine more boldly, to remind us that science isn't a collection of facts but a process of discovery. 3IATLAS embodies that process. It arrives as question, not answer, as mystery, not solution, as invitation to expand our understanding rather than confirmation of what we know. The invitation is profound. Join the cosmic conversation. Because that's what interstellar objects represent, messages from the broader universe. Not intentional messages necessarily, but information nonetheless. Data about conditions beyond our experience. Evidence of processes we haven't witnessed. Hints at the vast complexity surrounding our small world. Each interstellar visitor expands our context. Oumuamua showed us objects could be stranger than imagined. Borisov proved familiar chemistry exists elsewhere. Now, 3IATLAS demonstrates that even our expanded expectations remain too narrow. The progression is telling. We're being educated gradually in cosmic diversity, shown that the universe contains more variety than our local sample suggests, taught that our solar system, vast as it seems to us, represents a tiny fraction of possibility. This education is just beginning. If 3 interstellar objects have visited in 8 years, how many more are coming? What stories will they tell? What assumptions will they shatter? What new categories of phenomena will they reveal? We can't know, but we can prepare. Not through specific predictions. 3IATLAS has shown those fail. Through openness, through instruments that can detect the unexpected, through theories flexible enough to accommodate surprise, through minds willing to release old certainties when new evidence arrives. This is our task now, not just for 3IATLAS, but for whatever comes next. To build a scientific culture that thrives on anomaly rather than fears it, that sees mystery as opportunity rather than threat, that understands ignorance as the beginning of wisdom, not its absence. The fragments approaching Earth are teachers. They teach through their motion, their composition, their refusal to match our models. They educate through the questions they raise, the assumptions they challenge, the possibilities they suggest. We're students in a classroom without walls. Our curriculum is written in cosmic phenomena. Our exams come as unexpected observations. Our graduation depends not on knowing answers, but on asking better questions. 3IATLAS has given us new questions. Why do the fragments maintain formation? What force or property enables this? How common are such objects? What conditions create them? What can they tell us about their origin? What do they reveal about interstellar space? Each question opens entire fields of investigation. But beyond the specific queries lies a deeper question. How should we respond to cosmic mystery? With fear, curiosity, humility, wonder? All of these are valid, even necessary. Fear keeps us cautious. Curiosity drives investigation. Humility prevents overconfidence. Wonder sustains motivation. The balance matters. Too much fear and we'll miss opportunities. Too much curiosity and we'll overlook dangers. Too much humility and we'll fail to act. Too much wonder and we'll lose objectivity. 3IATLAS demands we find that balance. It requires caution. Fragments passing near Earth deserve respect. It rewards curiosity. Every observation reveals new facets. It enforces humility. Our models have already failed. It inspires wonder. We're witnessing something unprecedented. This balance isn't just scientific necessity. It's human wisdom. Because we're not just researchers studying an object. We're conscious beings encountering mystery. We're Earth life observing cosmic phenomena. We're the universe investigating itself through human eyes and instruments. The perspective shift is crucial. We're not separate from the cosmos studying it from outside. We're part of it, expressions of it, temporarily organized matter contemplating other temporarily organized matter. 3IATLAS and humanity are both cosmic phenomena, different arrangements of the same fundamental particles, yet what a difference arrangement makes. We can question. We can wonder. We can build instruments to extend our senses. We can create theories to explain observations. We can share knowledge across generations. We can transform mystery into understanding, even as new mysteries emerge. This capacity is our gift and responsibility, to observe what arrives from deep space, to document its properties with precision, to theorize about its origins and implications, to share what we learn with all humanity, to add our observations to the growing library of cosmic knowledge. 3IATLAS has given us that opportunity, not just to study an unusual object, but but to demonstrate human capability at its best, to show that we can respond to surprise with science, that we can face uncertainty with courage, that we can encounter mystery with both rigour and wonder. The demonstration matters beyond astronomy. In an era of global challenges, we need evidence that humanity can unite around shared questions, that we can collaborate across borders when faced with cosmic phenomena, that our curiosity and capability can overcome our divisions. 3IATLAS provides that evidence. Scientists worldwide are working together, sharing data instantly, building on each other's insights. The competition exists certainly, but it's productive. Who can observe most clearly, theorize most accurately, predict most precisely? This is humanity at its collaborative best. And we'll need this collaboration for what's coming. Not just the December passage, but the decades of analysis that will follow. The theories that will be proposed, tested, refined, rejected, replaced. The new questions that answers will generate. Science is a multi-generational conversation. We're adding our voices now, but the discussion will continue long after December passes. Future scientists will revisit our observations. With better tools, they'll test our theories against new evidence. They'll judge our response by standards we can't imagine. What will they conclude? That depends partly on what happens in December, partly on how we respond to what happens. But it also depends on something deeper. Whether we embrace this moment as an opportunity for growth, or resist it as a threat to certainty. The choice is ours. We can treat 3IATLAS as an anomaly to be explained away, forced into existing frameworks regardless of fit. Or we can see it as an invitation to expand those frameworks, to imagine new possibilities, to grow our understanding. History suggests which choice leads to progress. Every scientific revolution began with someone saying, "That's strange," with observers who noticed what didn't fit, with thinkers willing to follow evidence wherever it led, with communities that eventually accepted new paradigms despite their strangeness. We might be living such a moment, or we might not. Perhaps 3IATLAS will prove perfectly explicable once we have enough data. Perhaps the fragments will disperse normally after December. Perhaps our current physics, properly applied, explains everything. But even that outcome teaches us something. It teaches us the universe can create complexity that initially appears impossible, that natural processes can generate phenomena that seem artificial, that our first impressions, however careful, might be wrong. These are valuable lessons. They prepare us for future mysteries. They humble our certainties. They remind us that nature's creativity exceeds our imagination. They show us that wonder and rigour must walk together. 3IATLAS is teaching us to walk that path, to observe carefully but think boldly, to ground ourselves in data but reach for meaning, to acknowledge what we don't know while building on what we do, to face cosmic mystery with both scientific precision and philosophical depth. This is the real gift of interstellar visitors. Not just the data they provide or the theories they inspire, but the growth they demand, the expansion of our thinking, the evolution of our understanding, the maturation of our cosmic perspective. We're growing up, scientifically speaking, moving from a childlike certainty that we understand our surroundings to a mature recognition of vast ignorance. From believing our local experience defines universal law to recognizing infinite diversity. From fearing the unknown to embracing it as teacher. Atlas accelerates this maturation. It won't be the last interstellar object we observe, but it might be the most important. Not because of what it is, we still don't know, but because of when it arrives. At this moment of human capability, at this stage of our development, at this point in our cosmic education. The timing feels almost orchestrated, not by intention. The universe doesn't care about our schedules, but by magnificent coincidence, by the intersection of our growing capability and cosmics, phenomena, by the meeting of human curiosity and interstellar mystery. We stand at that intersection now, watching fragments approach, preparing instruments, refining theories, opening our minds to possibilities we haven't imagined, ready as we can be for whatever December reveals. The revelation might be subtle, a chemical signature that rewrites our understanding of interstellar space, a trajectory refinement that explains the apparent formation keeping, a spectrum that reveals familiar processes in unfamiliar combinations, or it might be profound, evidence of genuinely new physics, confirmation that our models need fundamental revision, observations that open entire fields of investigation, data that transforms our cosmic perspective. We're prepared for either, or trying to be. Because preparation isn't just about instruments and theories, it's about mindset, about approaching mystery with the right combination of confidence and humility, of knowing our capabilities while acknowledging their limits. This is the wisdom 3IATLAS demands. Not answers, we don't have those yet, but approach, attitude, orientation toward mystery. The recognition that we're participating in something larger than individual careers or national priorities. We're participating in cosmic discovery, in humanity's gradual awakening to the universe's true scale and complexity, in our species' slow education in cosmic citizenship, in Earth life's growing awareness of its cosmic context. 3IATLAS is part of that education, a lesson arriving at 68 kilometers per second, a tutorial in cosmic diversity, a reminder that the universe contains more than we've dreamed, a promise that mysteries remain for future generations to solve, but also a test of our readiness, ready to observe without preconception, to theorize without dogma, to accept evidence that contradicts expectation, to change our minds when data demands it, to grow our understanding even when growth is uncomfortable. December will grade that test. Not with a score, but with knowledge, with observations that either confirm our flexibility or reveal our rigidity, with data that shows whether we can adapt to cosmic surprise or remain locked in familiar frameworks. The universe is watching. Not literally, it has no eyes, but through the laws of physics that govern all things, through the patterns that emerge from complexity, through the stories written in light and motion, we're part of those stories now. 3IATLAS has written us into its narrative and we've written it into ours. The stories interweave, creating meaning neither would have alone, creating a moment of contact between Earth and cosmos, between known and unknown. This moment won't last. The fragments will pass. December will end. Atlas will continue its journey into deep space. We'll be left with data, theories, questions, and memories of when mystery came close enough to touch. But the impact will endure, not physical impact. Again, that's not the issue. Conceptual impact. The way 3IATLAS has already changed how we think about interstellar objects, how we prepare for cosmic surprises, how we understand our place in a universe far stranger than imagined. This is the deeper significance. Beyond the scientific data, beyond the theoretical implications, beyond even the philosophical questions, 3IATLAS reminds us that we're not alone in the cosmos. Not because it brings evidence of life, it doesn't, but because it brings evidence of cosmos itself, of a universe rich with phenomena, of space filled with objects we haven't imagined, of chemistry we haven't observed, of physics we haven't discovered, of stories we haven't heard. Each interstellar visitor whispers those stories, in languages we're still learning to translate, through phenomena we're still learning to observe, with implications we're still learning to understand. 3IATLAS speaks loudly in that cosmic language. Its fragments approaching Earth are punctuation marks in a sentence we can't yet read. Its anomalous behavior contains messages we can't yet decode. Its very existence poses questions we didn't know to ask, but we're learning. With every observation we understand a bit more. With every anomaly we expand our vocabulary. With every mystery we improve our questions. We're becoming conversant in cosmic phenomena. The conversation has just begun. 3IATLAS won't be our last interstellar visitor. Others will come, carrying different stories, displaying different properties, teaching different lessons. We'll be better prepared for them because of what we learn now. This is how knowledge accumulates, not in great leaps, but in patient steps. Not through single revelations, but through sustained observation. Not by solving all mysteries, but by engaging them with rigor and wonder. 3IATLAS exemplifies this process. It arrives as mystery and will likely leave as mystery. But between arrival and departure, it will have taught us to observe more carefully, think more flexibly, imagine more boldly. These are the skills we need, not just for astronomy, but for existence, for navigating a universe that's stranger than we imagined, for adapting to realities that exceed our expectations, for growing into cosmic citizens worthy of the title. The fragments approaching Earth are our teachers in this growth, silent teachers speaking only through motion and light, patient teachers following trajectories billions of years in the making, profound teachers carrying lessons about scales of space and time we can barely comprehend. We're fortunate students, living at precisely the moment when we can detect such teachers, possessing instruments to observe their lessons, connected globally to share what we learn, capable of preserving knowledge for future generations. This fortune carries responsibility, to observe carefully, to record accurately, to theorize boldly but hold theories lightly, to share findings openly, to acknowledge uncertainty honestly, to embrace mystery as opportunity. 3IATLAS has given us that opportunity. In 5 weeks it will pass through our neighbourhood of space. For a few days it will be close enough to study with unprecedented precision. Then it will continue its journey, leaving us with data, questions, and the memory of encounter. What we do with that encounter matters, whether we use it to expand understanding or defend existing beliefs, whether we let it teach us humility or reinforce arrogance, whether we see it as isolated anomaly or part of larger patterns. The choice shapes our future, not just our scientific future, but our psychological and philosophical future, our capacity to face the unknown, our willingness to grow, our readiness for whatever the cosmos brings next, because more is coming. If the detection rate continues, we'll observe several interstellar objects per decade, each one different, each one teaching new lessons, each one expanding our conception of possible. We're entering an age of interstellar archaeology, studying objects from other systems, piecing together stories of distant origins, learning about conditions we'll never directly experience, building a library of cosmic diversity. 3IATLAS is an early volume in that library, perhaps the most important because it's teaching us how to read, how to observe objects that don't match our patterns, how to theorize about phenomena outside our experience, how to remain scientific while acknowledging mystery. These meta-lessons matter more than specific discoveries, because they prepare us not just for 3IATLAS but for whatever comes next, for the 4th interstellar visitor, the 5th, the 100th, for the one that finally provides definitive evidence of something, we don't yet know what. We're building capacity for cosmic surprise, learning to expect the unexpected, to prepare for phenomena we can't predict, to respond with curiosity rather than fear, to see anomalies as opportunities rather than threats. This capacity will define our future. As we reach further into space, we'll encounter more mysteries. As our instruments improve, we'll detect more anomalies. As our understanding grows, we'll discover how much we don't know. 3IATLAS is preparing us for that future, teaching us to dance with uncertainty, to find stability in change, to maintain scientific rigor while embracing cosmic wonder, to be fully human while contemplating the inhuman scales of space and time. This is the ultimate lesson. We're not separate from the cosmos, but expressions of it. Not observers outside the system, but participants within it. Not strangers in the universe, but its way of knowing itself. Through our eyes, the universe observes 3IATLAS. Through our instruments, it measures its own phenomena. Through our theories, it contemplates its own patterns. Through our wonder, it experiences awe at its own complexity. We're the cosmos investigating itself. And right now, in this moment, that investigation focuses on fragments approaching Earth, on objects that shouldn't behave as they do, on mysteries that demand explanation, on questions that might transform our understanding. December 19th approaches. In the countdown to that date, every observation matters. Every piece of data adds to our understanding. Every theory, however speculative, expands our thinking. Every moment of wonder connects us more deeply to the cosmic story. We're writing that story together. Scientists and citizens, professionals and amateurs, skeptics and believers, all watching the same sky, all wondering what the fragments will reveal, all participating in humanity's cosmic education. The education continues whether we're ready or not. 3IATLAS doesn't care about our schedules, our theories, our expectations. It follows its trajectory, displays its properties, keeps its secrets. It teaches through being what it is, whatever that might be. Our task is to learn, to observe without prejudice, to theorize without attachment, to wonder without losing rigor, to face mystery with both courage and humility. In 5 weeks, we'll have our closest encounter. The fragments will pass through cislunar space. Our instruments will gather data at unprecedented resolution. We'll see details invisible from greater distances. We'll test theories against direct observation. And then we'll spend years analysing what we've learned, building new theories to explain new observations, preparing for the next visitor, adding our chapter to the ongoing story of cosmic discovery. But that's the future. Right now, in this moment, we wait, we watch, we prepare. We wonder what December will bring. We stand on the threshold of discovery, not knowing what we'll discover. This not knowing is sacred. It's the space where learning happens, where growth becomes possible, where the universe reveals itself through our patient observation and careful thought. 3IATLAS has brought us to this space. These fragments approaching Earth have created an opening in our certainty, a gap in our knowledge, a question mark in our understanding. Through that opening, new knowledge will flow. What form will it take? We don't know, can't know. Not until December 19th. Not until the fragments pass close enough for our instruments to resolve their mysteries. Not until observation replaces speculation. But the not knowing itself is valuable. It reminds us that mystery remains, that the universe exceeds our maps, that wonder is not childish, but essential. That the cosmic conversation continues, and we're privileged to participate. This is our moment, when humanity faces cosmic mystery with its full capability, when we demonstrate our readiness for whatever the universe reveals, when we prove ourselves worthy students of cosmic phenomena. 3IATLAS is testing that worthiness, not deliberately. It's just an object following the laws of physics, but effectively, through its anomalous properties, through its approaching fragments, through the questions it raises and the assumptions it challenges. We're rising to meet that test, with instruments pointed skyward, with theories ready for revision, with minds open to possibility, with wonder intact despite uncertainty. This is humanity at its best, facing the unknown with curiosity rather than fear, approaching mystery with rigor and imagination, using our brief moment of consciousness to contemplate cosmic phenomena. The fragments are coming. In 5 weeks they'll pass closer than the moon. They'll carry their secrets through our space. They'll continue their journey into darkness, but for a brief moment, they'll be ours to observe. That moment will echo through history. Future generations will study what we record. They'll build on what we learn. They'll judge how we responded to cosmic mystery arriving at our doorstep. Let them find we responded with wisdom, with careful observation and bold theory, with rigorous science and deep wonder, with the humility to acknowledge ignorance and the courage to seek knowledge. Let them find we were ready. Not for the specific phenomenon of 3IATLAS, nobody could prepare for that, but for mystery itself, for the universe revealing its complexity, for our assumptions being challenged. This readiness is our gift to the future. The observations we make, the theories we propose, the questions we ask, all become foundation for tomorrow's discoveries. We're links in a chain of knowledge stretching from curiosity to understanding. 3IATLAS has strengthened that chain. It's shown us new phenomena to investigate, opened new questions to pursue, revealed new depths in our cosmic ignorance, inspired new efforts to understand. These contributions will outlast December's passage. Long after the fragments pass, we'll be working with the data they provided. Long after the initial excitement fades, scientists will be testing theories against observations. Long after 3IATLAS returns to interstellar space, its visit will influence how we think. This is how science advances, not through single discoveries but through accumulated observations, not through answered questions but through better questions, not through eliminated mystery but through engaged mystery. We're engaging mystery now, with every telescope trained on the approaching fragments, with every calculation refining their trajectories, with every theory attempting to explain their behavior, with every moment of wonder at what we're witnessing. This engagement is sacred work. Sacred not in religious terms, but in human terms, in the sense that consciousness contemplating cosmos represents something profound. That matter organized to observe matter transcends mere mechanical process. We're the universe awakening to itself, and 3IATLAS is part of that awakening. A cosmic alarm clock jarring us from comfortable assumptions, forcing us to open our eyes wider, demanding we see what we hadn't noticed. The view is magnificent. Not just of the fragments themselves, but of the universe they represent. A cosmos rich with phenomena, filled with objects we haven't imagined, operating through processes we haven't discovered. This richness surrounds us always, but we need events like 3IATLAS to remind us, to break through our everyday blindness, to restore our sense of wonder, to reconnect us with cosmic mystery. That reconnection is happening now, globally, simultaneously, through millions of people following the story, through thousands of scientists sharing observations, through hundreds of telescopes tracking trajectories. We're united in curiosity. Despite all that divides us, nationality, language, beliefs, we share wonder at approaching mystery. We ask the same questions. We await the same revelations. We participate in the same cosmic moment. This unity matters. It shows what's possible when humanity faces something larger than itself, when cosmic phenomena dwarf our small concerns, when mystery invites collective investigation. 3IATLAS has issued that invitation. Not consciously, again, it's just an object, but effectively, through its anomalous properties that demand explanation, through its fragments that approach Earth, through its mysteries that exceed any single mind's capacity. We need each other to understand this, need global observations for complete coverage, need diverse theories for comprehensive understanding, need collective effort for adequate response. This is humanity's response to cosmic mystery. Together, we're stronger together, smarter together, more capable of facing the unknown together, more likely to learn what 3IATLAS has to teach together, and it has much to teach about interstellar chemistry, about fragment dynamics, about our model's limitations, about nature's creativity, about our place in a cosmos far stranger than imagined. Each lesson is precious, because we won't get another chance with this object. After December, 3IATLAS continues its journey. We'll have only the data we gather now, the observations we make in the coming weeks. This finality adds urgency, but also poignancy. We're witnessing something unique, experiencing an unrepeatable moment, participating in a cosmic event that won't recur. The fragments approaching Earth are writing themselves into history. Our history, Earth's history, the history of human understanding. They'll be remembered as the objects that challenged our assumptions, that forced us to think differently. That marked a turning point in our cosmic awareness. We're living that turning point, right now, as we track approaching fragments, as we prepare for December's encounter, as we wonder what revelations await. The revelations might be subtle, a chemical signature that shifts our understanding slightly, a trajectory that makes sense once we account for unusual factors, an explanation that's surprising but not revolutionary. Or they might be profound, evidence that reshapes our worldview, data that opens entirely new fields, observations that force fundamental reconceptualization. We're prepared for either, or as prepared as finite beings can be for infinite possibility. We have our instruments ready, our minds open, our wonder intact, our courage gathered. The universe is about to teach us something, through fragments of an interstellar visitor, through objects that shouldn't exist as they do, through mysteries that approach at 68 kilometers per second. We're ready to learn, ready to have our assumptions challenged, our models broken, our understanding expanded, our wonder renewed. This is what it means to be human in the cosmos, to stand on a small planet watching mysteries approach, to use consciousness to contemplate phenomena beyond comprehension, to face the unknown with curiosity rather than fear. 3IATLAS has given us this opportunity to demonstrate our best qualities, to show we can rise to cosmic challenges, to prove ourselves worthy of the knowledge we seek. The proof is in process. Every observation adds evidence. Every theory shows engagement. Every moment of wonder confirms our humanity. We're not just studying an object. We're participating in cosmic evolution, in the universe's growing self-awareness, in matter's contemplation of matter, in the grand conversation between known and unknown. 3IATLAS speaks in that conversation, its message encoded in motion and light, its meaning hidden in anomalous behavior, its significance revealed through patient observation. We're learning to hear what it says, learning the language of cosmic phenomena, learning to translate mystery into understanding, learning that some mysteries transcend translation. This learning never ends. Each answer generates new questions. Each discovery reveals new ignorance. Each moment of understanding opens to greater mystery. 3IATLAS embodies this endless process. It arrives as mystery. It will depart as mystery. But between arrival and departure, it will have changed us, taught us, challenged us, grown us. This growth is the real significance, not the specific data we'll gather, not the theories we'll propose, not even the discoveries we'll make, but the growth in our capacity to face cosmic mystery. We're growing through this encounter, becoming more capable of observation, more flexible in our thinking, more comfortable with uncertainty, more amazed by the universe we inhabit. December 19th marks not an ending but a beginning. The beginning of deeper investigation, of new questions, of expanded understanding, of our next phase as cosmic citizens. The fragments will pass, but their influence will remain, in the data they provide, in the theories they inspire, in the wonder they evoke, in the unity they create. We'll remember this moment, when mystery approached Earth, when humanity responded with its best, when we proved ourselves capable of growth, when we touched, however briefly, the infinite complexity surrounding us. This is our cosmic inheritance, not answers but questions, not certainty but wonder, not isolation but connection to the vast processes that shape reality. 3IATLAS reminds us of this inheritance, reminds us that we're part of something magnificent, something beyond complete comprehension, something worthy of our greatest efforts to understand. The effort continues, will continue after December passes, after the fragments recede, after the immediate excitement fades. The effort to understand, to grow, to become worthy of the cosmos we inhabit. This is our task, our joy, our responsibility, our privilege. To be conscious in a universe of wonders, to observe phenomena beyond imagination, to participate in cosmic discovery, to add our voice to the eternal conversation between mind and mystery. 3IATLAS has amplified that conversation, made it urgent, immediate, undeniable. The fragments approaching Earth force us to pay attention, to engage fully, to bring our complete capability to bear. We're answering that call, with instruments and equations, with observation and theory, with rigor and wonder, with the full spectrum of human capability. This is our response to cosmic mystery, not fear but fascination, not retreat but engagement, not silence but investigation, not isolation but collaboration. Together we face the unknown. Together we watch fragments approach. Together we wonder what December will reveal. Together we participate in this cosmic moment. The moment belongs to all humanity, to everyone who looks up wondering, who follows the story with interest, who feels awe at the cosmic scales involved, who recognizes themselves as part of something greater. We're all part of this story, the story of consciousness encountering mystery, of Earth life observing cosmic phenomena, of the universe knowing itself through human awareness. 3IATLAS has accelerated that knowing, forced us to confront our ignorance, challenged us to expand our understanding, invited us to grow beyond our limitations. The invitation stands before us, written in the trajectory of approaching fragments, encoded in anomalous behavior, expressed through properties that defy our models. We accept that invitation, with curiosity, with courage, with humility, with wonder. This is our moment in cosmic history, when fragments of an interstellar visitor pass closer than the moon, when humanity demonstrates its capacity for discovery, when we prove ourselves ready for whatever the universe reveals. The universe is vast, ancient, complex beyond imagination, but we're part of it, made from it, capable of contemplating it, and right now, through 3IATLAS, it's teaching us something new, something about its complexity, its creativity, its capacity to surprise, its endless depths of mystery. We're listening, learning, growing. This is what it means to be human, to face cosmic mystery with wonder, to pursue understanding despite ignorance, to find meaning in the search itself. 3IATLAS has renewed that search, reminded us why we look up, why we ask questions, why we build instruments to see beyond our limits, why wonder matters as much as knowledge. The fragments are coming. In 5 weeks, they'll pass through our space. They'll carry their secrets close enough to study. They'll continue their eternal journey. But for one moment, our moment, they'll be here, close enough to change us, to teach us, to remind us of our cosmic context. This is the gift of 3IATLAS, not the specific knowledge it brings, but the reminder that knowledge is always partial, that mystery is always present, that wonder is always justified. We receive this gift with gratitude for the opportunity to observe, to learn, to grow, to participate in cosmic discovery. The discovery continues, will always continue, as long as consciousness contemplates cosmos, as long as wonder drives investigation, as long as mystery invites engagement. 3IATLAS is one chapter in that eternal story, but it's our chapter, our moment, our encounter with cosmic mystery. Let us meet it with wisdom, with the wisdom to observe carefully, to theorize boldly, to hold conclusions lightly, to wonder deeply. This is the wisdom 3IATLAS teaches, through its impossible fragments, through its anomalous approach, through the questions it raises, through the assumptions it shatters. We're learning that wisdom now. We'll continue learning after December passes, after the data is analyzed, after theories are tested, after new questions emerge, because the learning never ends, and that's the deepest lesson of all. The universe exceeds our comprehension. We'll always exceed it. No matter how much we learn, no matter how far we see, mystery is infinite, and we're blessed to encounter it, to engage it, to be changed by it. 3IATLAS has brought that blessing in the form of fragments approaching Earth, in trajectories that shouldn't exist, in properties we can't explain. Yet, that word, yet, contains our hope. The hope that understanding is possible, that growth continues, that mystery yields to investigation, that wonder leads to knowledge, even as knowledge leads back to wonder. This is the cycle 3IATLAS embodies. From detection to mystery, from mystery to investigation, from investigation to partial understanding, from understanding to deeper mystery. The cycle continues, will continue as long as we maintain courage to engage the unknown, humility to acknowledge ignorance, wonder to sustain investigation. 3IATLAS has renewed all three: courage, humility, wonder. The fragments approaching Earth carry these gifts. Deliver them at 68 kilometers per second. Deposit them in our consciousness, we receive them gratefully, and return them as investigation, as observation, as the effort to understand, as the willingness to grow. This is humanity's gift to the cosmos, our consciousness, our curiosity, our capability to observe and contemplate, our determination to understand, even when understanding seems impossible, even when fragments maintain formations they shouldn't, when objects flash without cause, when trajectories defy our models, especially then, because that's when we grow most, when mystery is deepest, when wonder is greatest, when the universe reveals its true complexity. 3IATLAS is that revelation, approaching Earth, approaching our consciousness, approaching the moment when mystery and investigation meet. December the 19th, when the cosmos touches Earth, when the unknown passes close enough to study, when humanity faces infinity and doesn't look away, we'll be watching, with every instrument we possess, with every theory we can imagine, with all the wonder we contain. Because this is our moment, our test, our opportunity, our cosmic encounter. The fragments are coming, and we're ready. Ready to learn what they teach, ready to grow from the encounter, ready to be changed by mystery. This is the gift of consciousness, to witness cosmic phenomena, to seek understanding, to find meaning in mystery. 3IATLAS has activated that gift, fully, urgently, undeniably. The activation continues, will continue beyond December, beyond this object, beyond our current understanding, into the vast unknown that surrounds us, that calls us, that teaches us, that makes us human. This is our story, written in approaching fragments, told through anomalous properties, expressed in the language of mystery and wonder. We're learning to read that language, one observation at a time, one theory at a time, one moment of awe at a time. 3IATLAS is our teacher, and we're ready to learn. The lesson begins in 5 weeks, but the learning never ends. This is the universe calling us home, not to a place, but to a perspective, to the recognition that we're part of its vast processes, that mystery is our birthright, that wonder is our natural state. 3IATLAS brings us home, to wonder, to mystery, to our place in the cosmos. The fragments approach, the moment arrives, the universe whispers its secrets, and we listen. With everything we are, everything we can become, this is humanity, this is our moment, this is 3IATLAS approaching Earth, approaching us, now.